So yeah, let's get started. So tidyverse, what is and why tidyverse? It's like an ecosystem. It's a collection of packages that creates this smooth, nice ecosystem, and each package is dedicated for some aspect of data analysis, and together they really create some intuitive environment. And if you are familiar with one or two packages, then it's quite easier to pick up others. And after using it, so it's really easy, the code becomes really easily readable because all the functions have very intuitive, like human language names. So it's quite easily readable and reproducible, and overall workflow becomes quite nice. And like I personally have done projects which which was done only by base R, and I've done projects which was done by tidyverse. And I can like personally say that also my work was easier with tidyverse. And what's more important, I can go back and my code is way more readable and reusable basically after using tidyverse. So yeah, I'm very happy about it, and I just want to share some of my favorite tips of what to do with it. So these are the core packages from tidyverse, each one dedicated to one of our, like some aspect from data or programming. And this is the workflow, the full workflow from importing data to actually communicating our results. And today we're going to focus on this aspect, importing, tidying, and then transforming our data before starting actually exploring and understanding the data. And these together creates wrangling, taming our data for the analysis. And these are the three packages that I'm going to focus mostly during this talk, but hopefully it will inspire you to, explore further into the tidyverse universe. So about the data, I use for this penguin data, which is very, I just thought it was cute and adorable, and I'm going to use it, even though I know very little about penguins by myself. But these are the three penguins from like three species, subspecies of penguins from three different islands. And they've been measured, like their flipper lengths or the bead lengths and the weight also. And during some period of time. And we have female and male penguins, so it will be fine to just go with this data. First thing is to, well, I'm sure, like I hope that we all have tidyverse already installed and then loaded. And if not, this is the time to do so, because it might take some time, especially installing tidyverse. And so one thing about it is that what I always do is I always just go and import the whole tidyverse, so then I don't have to think about which function belongs to which package. But of course, you can always just pick a package and load it separately. And what we do is that I'm going to use from reader. This is read CSV, and it takes just file name and has some nice arguments that we're going to discuss shortly. And this last argument about the NA, it just we can just say which aspect to perceive as missing value. For example, missing a cell or some other, like 0, and that can be perceived as already a missing cell. So we're just going to load the penguin data. And so first, what I always do, this is like a structure, probably you already know the structure function, but it's like a deployer version of it glimpse, and it has just nice output of saying that how many rows we have. We have 8 columns and some, some variables about Iceland, the species, and year of measurement, with their personal ID. And what's also very nice is that each variable has its own type already. So we know how it's been read. And it's quite nice that read CSV already recognize that this is a date. So I don't have to convert it later. Another way, it's again with deployer, is to, see the first rows, and this requires always to indicate number of how many rows do we want to display. And yeah, this is how the data looks. I'm going to give it time for you to, you can also explore by yourself when you go to exercises. And there's like counterpart slice tail and slice sample. I like it very much because it gives some random sample from the rows, and it's always nice to see. And actually, this is the first work is already done. So yeah, time to go to exercises. And yeah, so you'll see, yeah, this is the exercise time. So you'll see a couple exercises. We need I think you'll need 2 or 3 minutes for this, just to, get a feeling of the data on your screen.
Let's just briefly check in. Did everyone manage to download the material from the GitHub repo? Let me just also share the link again. Yeah, I'm gonna share the link right away. Yep, here we are. The recording will afterwards be posted on our YouTube channel. And then we're gonna also share the link with everyone who attended the meeting so far and everyone who wanted to attend but couldn't make it. So yeah, I think right after this, maybe just give me half an hour or something, then I can upload it. And depending on how fast the internet is, it will be then uploaded. But yeah.
Maybe we can go again over the slice head. Oh, it's already. Never mind.
So yeah, I think this time's up, right, for the exercises?
Yeah.
Yeah, right.
Let's just check. Did everyone manage to open up the exercise, or you're still downloading the GitHub repo? Just give me a brief yes on yes, done, or no, not done, just so that we know.
Okay. Done. Nice. So yeah, that was quite easy warm up. So I think it's safe to just go on. And also, folks, I also have, for every exercise, I do have solutions with me. So if you have any questions and if you couldn't figure out some exercise, you can just maybe put in the chat. Each exercise has a number, so I can then go to that, because yeah, otherwise I will skip the solutions, because I think now I can safely skip the solutions. This was quite.
We had one question, what slice head does. Maybe that was already answered, but maybe you can also just briefly.
Yeah, as slice head and as slice tail, they just provide first some number of rows. So based on n, it can be just one. So it will just show you first row, the entire row of the data, or like here we have 5. And with the tail, it's like bottom from the end tail of the data, like last 5 rows or last, whatever we want. And same goes with sample. It's just random, but the end dictates how many rows it will print.
Yeah, I always like to imagine this like a cat, so that the head is like the beginning of the cat and the tail is like the end.
Yeah.
So.
So here you go. Always think of a cat. And then we have, so there are some questions there. So when we saw the data, we had some variables that were not quite in the right type, because we had island, we have sex, for example, that needs to be converted into a factor. Well, it's nice to convert them into a factor. And then we had, I'm sure you also realized that we are skipping one row, well, not skipping, but dropping one column, which is a date, because we have kind of double. We have year and we have date, and the measurement's been done only one day in November, so it doesn't really add any much information. So we can just drop one of them. So there's few, like many ways how we can transform variables, but here I just have two of them. One is to use this per package and the map function. And what a map does is that it takes, now we just indexing. So we are saying that, hey, give me all the rows of all of these columns. And then I'm saying with the map that take this, all the rows of all these columns. And this is a function. So it takes a vector or a column or the part of the data set and then a function and applies that function to each value of the vector. And therefore, when we run string to just check, we can see that we have vectors with right levels. Another way to do so is that, well, if our data is not huge, very big, then we can reload it, re-import it with, again, with read CSV, or depends on the read domain, basically using reader. And this time using this argument call type, for which gives us an option to specify a column and then say these are these functions. For example, call factor to turn this column into a factor, and then giving it which levels we need. And for skipping the row, we can right away, while reading the file, we can indicate that I don't need this column, this variable date, just skip it, and it won't read it. And we here I just transformed the first one, but there's more to transform. So here again, this is the converted version of just print of it. So this one is vector, as you see, and these are still characters. And this is very nice because these are all the functions that we can use with call type. So I use call factor, but you can turn to logical or numeric and even date, but you have to indicate the format of the date you want. And with this, it's another exercise time, because then we have to transform, you have to transform for the rest of the data in the right shape and drop the unwanted columns. And yeah, I assume everyone has now the and it probably just takes a few minutes to, like 2 or 3.
Yeah, and if you are done, just let us know again in the chat by typing done, so that we know whether we should give you a little bit more time or whether we can move on.
Nutsa, do you have to specify all column types if you use it, or can you only say one column that you're interested in and the rest will be default?
Yeah, rest will be default. That's the thing. Yeah, just the ones that we have to transform, and the rest is just goes with it. Because, for example, like here, it read everything, but just kept everything as it was, and only these species was transformed. That was the question, right? That was the
Yes, yeah.
Yeah.
That's
so
nice.
so unless you drop something here or stuff like this, it just reads the whole file, but in advance transforms some stuff.
Thanks.
How's everyone doing? It's really difficult to tell online, so
Think a little bit.
Yeah, I mean,
we did not get
Hi.
any.
I actually have one question. So when you import the data set in the environment,
Yeah.
there is like a button import data set. There you can already change the types, right?
Probably. But
so that you
like,
don't have to rewrite everything.
So you mean by like a without code when you actually put import?
Yeah, without code.
Yeah. Like as I said, there's like many ways that you can
Okay.
change this is just like two that's well with the tidyverse and also with the tidyverse there are many ways to change, but if you use this GUI then yeah, sure.
Yeah. Okay, thanks.
Okay. Do we have any other questions?
And I think we can also go on the solution.
Yeah, maybe let's move on then, and then you can just let us know a little bit on the solution part.
Yeah. So this was the actual. Maybe you can even maybe just type into, because then the next exercises are kind of assume that this was transformed, but also if not, it's okay. So that was the thing. So what we do here is that we take this call type argument and calls function and saying that the first species column that we transformed already, and we can just add up any column you like with any type you like. It just happens so that this is factor we are using. So island and sex into factor, and even I think I've done it without indicating I say you can also, by the way, you don't have to indicate these names of island names, and it will still put it in the right. You know, for now it's fine. It will just assume the level of the vector for now, and then date skip call. That was the it was the whole code, and then just to see, just to double check, basically that we've done everything we've done. So this is how it should look on your screen as well. Do we have questions about
We have
that?
one question, but I can do this for you, so you don't have to worry about it. So Margot is asking whether we can insert the code in the chat. I have the solutions file, so I can just insert the code there. So
okay, I can.
Yeah.
Okay.
I'm just gonna
Sure.
insert it right now.
Okay, then, okay, so what we did was that, so we imported the data, and thanks to Reader, we did some small cleaning already. And now we are going to tidying part of our data. And before I go to tidying, I want to explain pipe operator, which is one of the very convenient thing that tidyverse offers us. So what this operator does, it looks like this, is that it kind of chains different functions together and gives one output, one final output. So if you just, we know this basic, very basic style, right? We write function, we give it some argument parameter, for example, data in our case, and then some arguments. So imagine this expression is same as this one. So we take data here, we take data and then pipe it to this function and some arguments, and it will give us the same output. So another way of putting it is this one, like nested functions. Then we take first function, we take some some input parameter, and then this, whatever the output is, has to be the input of this function. So instead, using this abundant nested brackets, we can write like this. So that A is first transferred to function 1, and they have output, and this output is chained back again to function 2. So another way of seeing is just chaining together, or piping, like water flowing into a pipe, like chaining together some actions we want to do. And instead of like saving intermediate steps, we don't care about intermediate steps anymore. We just want the final output. So beginning and end is what matters, and intermediate functions not the. So another way is to like read it as then, like in a more of a human way. So if we want to make pasta, we take pasta, then we boil water, then we put pasta, and the argument will be okay, venom. And then we add sauce, and then again, and these can be like functions, and yeah, in the end, so we just have a beginning, and it's kind of, so I will use a lot the pipe for the rest of the talk, and you'll get the idea, hopefully. So now let's talk about tidy data. And data is considered tidy when these 3 commandments are met, and one is that each variable has to be in a 1 column, and each measurement or each observation is a row, 1 row, and then each intersection of each column and observation gives a cell, and this cell has to have only 1 value. For example, if we have some random data of some 3 people, which who were just tracking their weight over some season, over the year, here we see that, okay, this spring, winter, and summer can be itself values of 1 variable, which is season. So instead, we can tidy up this data and put it like this. See, now we have into season, which has 3 values, spring, winter, or summer, and each measurement of weight. So now, and as each measurement, like in spring and the weight, are actually in the 1 row. So it's more of a tidier version of the data. So how we do it in R, we use tidyverse package for this, and it has this pivot longer function, which does, so we take data now, we pipe it to pivot longer, and then we indicate which columns we want to transform, reshape, and give it to, so we say, take these columns, and whatever was the column name, just put it into season. And wherever was the values in those columns, just put it under weight, and we make up these names. We can call them anything we want, and we just retain missing values. And what happens is that exactly what we had. See, spring, winter, summer went into season column, and the weight, it's longer because, well, it's quite arbitrary what's longer than what, but in this case, it's like has more rows and fewer columns, so it's like an elongated version. And just to demonstrate, we have like complementary of pivot longer. This is pivot wider, which is like a mirror function, or basically of pivot longer. And what it does is on the other side, maybe it's easier, so just takes names from season and takes values from weight and spread out into separate columns. So sometimes they like data sets need longer, elongation, or getting more wider, depends. But these functions exist, and our penguin data also needs reshaping. So hopefully that will be successful. So you have to do it for me now.
Do we have any questions so far?
Yeah, I wonder.
Maybe someone in the chat can answer why this is such a common operation in R, or actually in any data science.
It's a question to me, but like
No, I think the audience would like, I would like to know if they know why we actually make this operation so often. It's yes.
In a way.
Yeah, we have some responses. Prefers long data for repeated measures. Then we have, my experience is that the statistics I run need to be in long format, but intuitively we store it in the wide format. To make life easier, it's weird as SPSS seems to prefer wide. A range of reasons.
Yeah.
Yeah, when we get the data from clients and colleagues, the format is easier to plot with ggplot, I guess. Yeah, that's really true. Valo also adds to it, easier for plotting.
Yeah, so I see really a wide variety of understanding. And I cannot speak for other languages, but I really feel it's, from a coding perspective, just easier to manipulate. If you want to group by something, it's like, yeah, winter or seasons. It's just really hard to use this wide format, which is a lot easier indeed intuitively to both write and read and compare. But from a coding perspective, it's not. So I kind of think it's just a coding hack, but I personally would also have to check that. But it's interesting to see what people think.
Yeah, maybe also if we have like lots of features and we want to kind of collapse too, and it's right there, we can always just unite under one umbrella, right? Like season or dimension or something. Yeah, if the scale permits. Yeah, lots of reasons maybe.
Yeah, we also have two people saying that they're so used to long that now the wide format seems not intuitive anymore. Yeah, and sometimes people set things up for graphing in Excel. Excel, another story, right? But yeah, cool. Really nice that we had so many people responding to this.
Oh yeah, like for now, our peak with data is getting wider, not the longer. So it's other way around, actually.
Yeah.
But yeah, maybe it's not intuitive anymore.
Yeah, in exercise 3, it's now about getting it into wide, right?
Yeah, it's just that, just so that we have like right format, and then we can, and just using once the pipe, which is just one pipe, just to get the hang of it. I think it should be done because half of the code was written already.
Yeah, maybe let's check. Who's done? Give me a done again. Oh,
yeah, nice.
Yeah, we have some coming in. 2 people so far. 3.
Okay, so
yeah, I mean, yeah, I think there's more coming in. So maybe you can just briefly go over the solutions and then we can move on, I guess.
Sure. So this was the first part, very small one, just to get the, just to, get the filling of the pipe. It also can be, it can be used outside of tidyverse. There's no, it's not illegal outside of tidyverse, but yeah, and the penguins. Now we're going to actually, the whole time, we're going to use this data frame, penguin white. Yeah, just we needed measurements and values to be spread out for it. And then we have one row per each penguin in this way. Yeah, and we just, here's our data set with the first 8 rows of the data set. And this way, well, of course, like tidyr has lots of other functions, and the whole workshop can be done probably only talking about tidyr, but we just, did this part, and we're moving to actually to transform the data. And yeah, I mean, if we need to take a break, if you're up for a break, maybe You can do, or I can also give it to like a 10 minutes.
Yeah, maybe that's a good point. Maybe let's do 5-minute break. So let's be back here at 19:23.
23.
We can also do 25. Let's maybe have a brief break so that we can grab another drink, run to the bathroom or anything like this, and then we'll be back here 19:25. Yeah, maybe easier to remember than 23.
Okay, see you soon.
Okay, cool. See you in a bit. Hi, Zoe. I saw that you just joined. Just wanted to let you know that we're just on a very short break until 19:25, and we'll continue right after that. Yeah.
Hi.
Hi.
How many time of break?
Break until 19:25. So maybe five minutes.
I am in 5 minutes. Okay.
Yeah. Okay.
Because I am in Mexico.
Okay. Yeah.
That's
5 minutes. We'll be right back.
I hope exercise was done, and now we have wider data, and with factors. So let's transform the data with dplyr. So first one, we're going to go over columns first, how to work on columns, and then we're going to go to rows. So first one in line is select, and select takes columns as names, and basically it's a way to zoom in our data. If we have like 100 features, variables, we could just pick 5 and then work on these 5, and select helps with this because every dplyr function returns a table. Table is a tidyverse version of data frame, which is just nice version because it just prints data only whatever is fit to the screen. It won't go over. So it's it's for now it's just data frame version. So every verb in a dplyr gives back the output is also a data frame, not just a value. So with select, we do this. For example, let's just select ID, and then with this column, just select whatever's from species to year, and it's inclusive. So year, including year. And just for convenience, let's just print random 5 rows. Also everything with pipe now. And here's the output. We only have ID, and from species to year was these columns, first 5. Then what we can do actually is not just select, but deselect, so to say, with a minus sign. So I'm just saying, hey, just drop whatever's from year to ID, and the rest will be retained. So here you go. We don't have year and ID anywhere anymore. What's nice about select is that it has these helper verbs, what we can do is that not just give the exact name of the column, but we can just say, hey, just give me whatever starts with A, or if it matches something, or if it contains some wording, so that pattern, and then it will look for us and give us back. So for example, with this, select whatever starts with Bill, and we only have 2 columns. And then of course, just 3 random rows. It could have been also with and with, so it's very, very convenient. Another way is to use select, is to rename columns. And what we do here is that see, red is new name, and the rest is the old name. So new name equal and assigned to old column, and the old ones are just dropped. So then it means that if we have another chain here, another pipe, we always want to refer to new names. It will be converted already within the pipe chain. So, and it just gets selected on this one. So we rename, but we also select. So we only have these 3 columns with new names. So then we have so everything just gives everything. It's straightforward, but we can use it to rearrange it with select. What I mean is that, okay, let's just reshuffle and put ID and text the first 2, and then the rest goes with everything. So if we do this, see, we have ID and text, and everything goes after this. So it's just relocating basically. And one small thing is just, I love it, it's drop now, which just, it just piped, it's a own standing function, and it just gets rid of every missing value we have in the whole data. It's like, be careful with it, but for the convenience now, we're gonna use drop now. That's one way to do it. So yeah. And actually we do have relocate function now. This is also a new one in the player. And what it does, it's more of a subtle way of relocating, because we can actually indicate that I want this column after this, or before this, or I think someone just turned on microphone.
Yes.
So yeah, so here what I'm using is this last column, and what I'm saying here is that, okay, take from year to ID first, and then after this, and okay, they take this and put it after whatever the last column is in my data. And as we see here, we have year and ID all the way back. But we can also put somewhere in between if we indicate the name of the column. And where is another helper verb. And actually, I'm introducing it with select, but we can use with other deployer functions too, like mutate, for example. We can also use this helper sometimes, for example, where. And what it does is that it takes a function as an argument. For example, is numeric is a function. And if it's true, so it takes a condition, it checks the condition. And wherever this is true, it selects that column. So it selects based on this condition, wherever we have numeric columns. So here we just put, and it's, I've used it so many times, sometimes it's nicer to just divide into characters and numeric, at least, and see if it's big data to what we have. So it's quite easy in one line of code, or 2, okay. But it does the job. And what else? No, nothing else. That was all about select and columns. So it was quite a lot of information. So this part of exercises have some exercises and plus bonus exercises. And don't feel any pressure to do bonuses. It's just for you. If you have extra time, just go over them. But otherwise, it's totally fine. Just do the rest of the exercises and give us a shout when you're done.
Do we have any questions so far? People probably just really eager to do the exercises. So
yeah, it's always better to try yourself. You understand more.
Yeah, true.
Rather than me talking.
But yeah, let's give people, what would you say, maybe 4 or 5 minutes?
5 maybe for these,
5?
especially
Okay.
if someone wants to try bonuses. These are like 2 blocks that have bonuses, so more time.
We have a question from Margot. Can you select and then slice head and slice tail in the same pipeline? When I want to see the beginning,
Okay,
see
so actually
beginning and end of the data at the same time.
Yeah, this is a very good question actually. So short answer is no, because what happens in the pipeline is that whenever you when you select something, you only have the selection to go over for the next pipe, right? So if you select like 5 out of 10 columns, then you only work with 10 columns. And then if you in the pipe, you indicate that, hey, I want like first 5 rows out of this data, then you get 5 rows. But then if you indicate in the bottom that now I want 3 rows from the tail, what it's going to do is that it will give you bottom rows from the first half, because it only has first 5 rows to work with. So every time you are inputting something from the pipe, does it make, like, how can I better? I need to illustrate.
Yeah, I think it makes sense, right? So you're just passing like the first 5 rows. And then if you do like the tail of those first 5 rows, you actually just pass on the
so here
middle 3 rows, like
like
skip
this
the first
one.
2 and then just give the third one. Yeah.
So each one, after each pipe, the input is the previous one. That's the thing. So you don't get the whole data for free anymore. But on the other hand, it's nice because the original data won't get modified unless unless you overwrite it with the same name. It gets intact, so it stays intact. So that's also nice. On the other hand, I hope that will
Did this
makes
answer
sense.
your question, Margot? Yeah, thanks.
Yeah, cool.
All right. To everyone else, just give us a done again if you're ready.
2 more exercise blocks to go, and that's it.
So there's another slice argument that's just called slice. And you can give the index of the row. So if you know how long your data frame is, you can give the first 5 and last 5 indexes. And then you can see those at the same time.
I think so. I'm not sure whether it has this argument, but with the pipe, if you're piping it in on top of each other, then
it's not on top. It's just one argument. It's called slice. It's like the
just slice, not just slice head and tail, but sorry, yeah, okay, now I get it. Yeah, slice and then
just the index of the rows you want to see.
Yeah, that's
so
handy.
slice head is like a sub function of the slice function.
Actual slice.
Yeah.
We have also a question from Marie. What if I want to select column 1 to column 10, but not column 8, for instance? How would that look like?
Okay, so there's, well, one way is just this straightforward way is to just, you know, name all the columns, is like 9 of the columns except that one. Well, a smarter way is to, and that will give you other 9 columns, just 8, not 8. But then if you have some smarter ways, if you have some patterns there, for example, we have some millimeters here or some BL or some, you know, some word that repeats or some pattern, then you can use the helper verbs, either contains or match with the even regular expression. So that will can give you. But if that wouldn't work, then what you can do is that maybe you can select and then deselect and then omit 8 one, you know, like with the minus. And it can be done, I think, within the same pipe even. I think with the select, that's the weird part. Then you can select and then deselect in the same parentheses, and it would work because it gets referred to whatever it has. I would, not 100% sure I would try it, but that's pretty much, or maybe yeah, just 2 pipelines.
Yeah, that makes sense to her. And also
Yeah.
Lei is asking, can you use brackets?
With what?
Lei, would you like to clarify? So to only select some columns.
With select, I think brackets. I never used brackets with select. No, I think the whole idea is that you don't need to. You're not actually indexing with select. You're just giving select the name of the columns as arguments. It's not actual indexing like with the base R. So this is what I mean. Or maybe this can be even. Maybe the more foolproof would be to do like this. Oh, sorry. Yeah, but what I mean is that it had got frozen for me. Sorry, guys, but like here, and then piping and then selecting again, and then my -8 column. Basically, I think you get the idea. Yeah, but select again there. Yeah.
Cool. I think that responded the question.
Yeah. So.
We're not getting any done, so I'm assuming that you're all just super eager. Maybe we can just move on.
Yeah, for sure. Maybe you anyone wants to just see one of the solutions and then just give me a number or some indication of it, and then I'll go over that solution precisely, rather than, because these were the without bonus solutions. So we could just select and then deselect, but I call it deselect, it's just deleting, omitting this column. And what I wanted to show and with the exercises was that, see, we have 2 similar syntax except select and rename, and both are kind of renaming. But what happens when rename is that none of the columns go away. So we are not selecting anything, we're just renaming. While with the select, as I showed you, we renamed, but also then retained only those columns. So that's the difference I wanted to demonstrate with exercises. And then these are the bonuses. So maybe I should just go on, and in the end, if we have time, I can always come back to these bonus solutions, right? So yeah, I'll just go on if there's no pressing. Yeah. Okay. So mutate. Mutate also works in columns, but what it does is that with mutate, we form new columns. We add up new columns based on some calculations that we can perform on existing columns or some operations. So what I mean by this is that, for example, here we are saying that, okay, just select everything that contains in the name millimeter, and it does. And once it's selected, I'm saying that, okay, I don't want millimeters, I want the measurements to be in centimeters. So let's calculate this. And I'm making up the new name for the column and then assigning it to the existing column divided by 10. It can be anything. You can just calculate, I don't know, z-score, for example, for the column and do it. So what's nice that we don't need any for loop, it's vectorizing. So it divides 10 for each element of the vector. And for each one, I'm having 3 now. And what it does, see? And the notable part is that the old columns don't go anywhere. They are retained, but we get the new ones with the centimeters. So that's what Mutate does generally. Then there's a new function called across. It is like a helper function. It can go with mutate or summarize or even select. And it takes 2 arguments. One is again like pretty much like select. It takes column names or some matches, also with a helper verb, some column name indication, and then a function to apply on that column. So here, the function can be either the pre-made function, like, mean or median or any max, or we can also make custom functions with it. So here, again, like the last one, I just, selected something with just this measurement in millimeters. Yeah, I just dropped now missing values. And then I'm saying, okay, no, mutate across everything, and we've seen this everything also goes with select, so it does every column. So across everything, whatever it is, just divide by 10, each element divide by 10, and this tilde is the indication of a function. So this expression is read as a function, so it reads that, okay, this is the argument, and argument in this case is every element of every column, and it divides by 10. So here we have but we didn't add any new columns. We just mutated the existing one based on across and on everything. So here's just the calculated version of those columns. And another handy function which I use a lot is if-else with mutate. So what if-else does is take some condition and some 2 options, whether what should happen if the condition is true or false. So for example, if we want to let's divide our penguins into smaller and more heavier penguins. How can we do it? So let's first calculate some median, and we have body mass in grams for penguins. We calculate the median mass and then just select some, just sex in the body mass of the penguins. And then we say, okay, give me size, and size will be if the body mass is more than equal median, then we call them large penguins. And if it's smaller, we call them small penguin. And yeah, it just gives another column, and it's just a new categorical column dichotomized based on the mass, whether it's small or large. That's what, and it's vectorizing because we don't need for loop for this. It can just iterate on every element by itself. And that was mutate, I guess. And
we have 2 questions, maybe before we move on to the exercises.
Sure, yeah.
So the first one is, what is the difference between across and map?
Well, map, I think with the map doesn't go, I don't think map can go with the mutate and select. I think across comes from deployer, and I think it very well is for the helping purposes with the summarize or mutate. But in a way, and map can be used also by its own. Map can take a vector, not necessarily even a data set, and can like map. I would say map is more similar to those functions that are apply or supply. I think it just goes over each element and applies a function. But that being said, these are quite similar because also this function is called pure-like function. So I think across was pretty much inspired by map, but was kind of like created for the player. And I'm not sure, I haven't tried whether we can just use map here. And I think it will go same way, but I'm not sure what will be the like. There should be some subtleties there, and I have not gone that deep. So if anyone knows, please help. But yeah,
maybe
that's how
also
I understand.
Yeah, nice to try out, right? So just to see what the difference could be.
Yeah, sure.
I think also the default return argument of across is just a table again, while map usually gives back a list. And you can also do different things. So
that's,
but indeed it's from
default.
different packages.
Yeah, map is more not object oriented, but more of a broader map has broader scope, I think, right? Than across. Yeah, that's how I understand.
Okay, cool.
Okay,
we
so
have one more question.
Mhm.
It's from Manel. She's asking, could you please again maybe mention the term for the tilde.x or explain what that meant?
Oh, so what it means is that these are called inline functions. So you can also check out. So what it does is that this tilde just the indication that this is a function. It's not just an expression anymore. It's a function. And this dot x is an argument. So just any function takes one or several arguments. So this time we have one argument. And this is just, it can be anything else. It's just saying that, okay, we need this argument to be divided by 10, but can be other stuff too. So since also map and also across, since they take a function as an argument, and also where, when I mentioned the where helper verb, it also same, right? It also takes function as an argument. If we don't give it like a pre-made function like mean or round or something, then we have to indicate that, okay, we have to indicate like this tilde, and then we have an argument. And argument in our case is every element of every column that we are selecting now with everything, right? But it can be also one column. And we're just saying, okay, just divide by 10 each element. So that's the expression. And it can be a bit confusing in the beginning. It takes some time to get used to, but it's quite handy if you manage to practice on this. It's quite useful. And yeah, any more questions?
Yeah, so it's clear. So thanks, Nutsa. No, I think we can continue with the exercises part 5 if we don't have any further questions.
Yeah, and also like take 5 minutes for this exercise probably, because it's also a bit heavy, I guess. But yeah, if it's not, it's good. Then it's good.
Yeah, same here again. Take the time, no rush, but let us know as soon as you're finished with like a small sign in the chat. That's so true, Margot. I think that's very often the case.
It's relatable.
I feel there are too many functions in the tidyverse. I'm impressed how many new things there are.
Yeah, the last update like gave many new functions. Yeah, they also, I forgot to mention, but they kind of exchanged this pivot longer and wider. These are the substitutes for this spread and gather, and they won't be continued. So these are the newer of this spread and gather with the tidyr. So lots of changes.
I like your question, Sarah. Really nice one. So for anyone who hasn't looked in the chat yet, Sarah's asking what's everyone's favorite function so far, and any surprising discoveries you want to use in your own work so far. We have one drop NA or drop na. That makes life a lot easier.
Yeah, but also be careful with it because just eliminating all missing letters. But I think also Dropna is a bit more recent because back then it was Isna with filter. Yeah, Relocate also. Me too, actually.
Yeah, we have someone that wished they had known more earlier about Relocate.
Yeah, that's also me too. Me too. Yeah. I think that's also a bit earlier, not earlier, but recent, more recent.
Okay, how's everyone doing?
So no pressure on bonus exercises. Really, they are really just there for you. You can always go back. Then.
Yeah, maybe let's move on.
Yes,
maybe you can just explain some of them.
So what I wanted to show with the exercise was that the transmute, which I haven't mentioned, it's a sort of, it sort of works as mutate, but the output is different because what it does is that it only, well, mutate adds new columns and retains the old ones. But with transmute, you only get the new ones. So the old ones are dropped, so it's replaced. So it's different option, but beware that with transmute, you lose the old columns also. That's the only difference. But sometimes it's handy. And this was just a combination too. See, with across now we just use round. This is built-in function, right, in R. So we didn't need tilde or any complicated stuff. We just use built-in function, and across is happy with it. It's fine. Yeah, rest was quite straightforward. And now it's about rows. And with rows we have a filter. And with filter, we have also arranging option of the some values. So what I mean is that filter takes columns, again, column names like select or any other, but we give some condition, or either, for example, like this, filter year column, wherever it's equals to 2007. So it's a condition. So it checks every row in this column, every element, whether it's true or not, and retains only the rows that are true with this condition. And then what I do here, just for the sake to show you, is that arrange build depths, for example, by descending order. So arrange just reorders whatever's there, first with filter, and then just to see who has the deepest BL, and then decreasing order. So here's what we get. First, we only get years by 2007 and not more. And then, this is in the descending order. And default with the range, just with default, if we don't indicate this, it's ascending order. So that's the only thing with it. It's quite straightforward. We can also, for example, if we have two conditions like this with a comma, it's like the logical operator AND. So what it reads is a filter island, that is dream only, and sex is female. So it's AND. We can also use other logical operators with it, for example, OR, but with AND, we don't need it. It just column and it reads like this. So it's default. And then I'm using something like with transmute for now, and to just, to transfer it to calculating in kilograms. And then let's see who's the lightest female on Dream Island. And oops, sorry. And yeah, here we go. This is only, so we went down to one value here, and its body mass is only 2.7 kilograms. But what's important, it's still a table. Even if we have one value, it's still a table. It's a one-to-one table for this, because every deployer function takes a data frame and outputs data frame or table. I'm using interchangeably now, table and data frame. And last two, this is very last, are the grouping and summarizing. What I mean by grouping is that if we have, for example, we do have like several groups, right? Sex or islands, where they come from. And instead of, for example, operating on this full data, we can just take group by and take groups. And for each group, perform some calculation or some operation. And in this case, with summarize, we can summarize. And what summarize does is that it just collapses the whole rows under one calculation. For example, I'm asking summarize to first grouping by sex, and then I'm asking, okay, for each female and for each group, either female or male, calculate how many are each, like how many rows simply are there, and then calculate for me average mass, so average body mass. So it will be one value, right? So this is what I get like grouped into female, male, and for each one calculated total number. And we have more males and females, slightly more. And then the average mass, and well, yeah, females are lighter than males in penguins, apparently. And this was quite short, but still these functions are very useful. And I want to point out that I think I don't have exercises for group and summarize there, but they are really, really useful. So go check out. And with summarize, you can use across and where. So all the functions, all the helper verbs I mentioned with select and mutate, you can use with summarize. And yeah, just play with it. It's really nice functions. And if you have any questions, I'm going to answer. Do we have any questions? I can't see.
We don't have any questions at the moment, not in the chat, but if anyone does have questions, please shoot.
And we need probably like 2-3 minutes for this, like only a few exercises left. So
Okay,
it's quite, should be easy.
I have a question meantime.
Yes, please shoot.
Yes.
I feel a little bit like not comfortable asking so many questions.
No, it's fine. It's totally fine.
I'm wondering about the volgorde. How do you say volgorde? Volgorde? Order. I'm wondering about the order. If I start first with group by and then I use mutate, and if I do differently, if I do first mutate and then I do group by.
So with the group by, what we do, then we're telling, we're setting that whatever we do, it has to be done for each group separately. With mutate, if it does it, if it differs or not, I'm not sure. I think with mutate, it still be the same. It still can be same effect, but essentially every calculation that is done, especially with summarize, and after it's grouped, after the data is grouped, then every calculation is done per each group, for each group separately. So it's not all over the data anymore. But with mutate, I think the result, the output will be the same. It's just that, sorry?
Or you can mutate, but it would do it over the entire data frame.
Yeah, still.
Then you would lose the distinction between your groups if you don't group it first. So order matters, basically.
But if you first group and then mutate, it will be all over the data, right?
Yes, but per group.
Per group.
As you explained, right?
Yeah.
So it's really, as you explained at the beginning with the piping, it's really step by step. It's like a logical order. So one follows the other. So if you change the order, it does something different, basically.
Thanks.
Okay, shall we maybe move on? Or do you still need more time?
No, I'm fine if we're done. Yeah, sure. So that was the solutions. Nothing very complicated there. Yeah, so I just wanted to show what we missed on this workshop. A lot, but I hope that you also can take a lot home. So within it, these are another like core packages, basically, each one dedicated, starting from visualization to, these cute ones are all about factors, or for modeling, or even just dedicated for just dates, about manipulating dates and times. So really worth checking out, and just picking the ones that you use for more often, and have it on your disposal. And there's also lots of resources out there, and it will be easy to find, but like just go-to still, I think, is the beginner's guide for R for data science, which also explains a lot about R and generally the data analysis, but also within the framework of tidyverse. It's quite nice to have it. And also, if you go to tidyverse.org and learn, you get lots of more other books and resources, lots of pointers where you can learn more. And of course, the GitHub repo of tidyverse. It's another place to check out for sure if you're interested. And actually, that was it for me. And thank you so much for listening, and all these very clever questions, which made me think and made me want to check out some stuff myself. So thanks for having me.
Thanks so much. I mean, you would really deserve a huge applause. But yeah, you can see it in the chat that there's a lot coming in. So thank you so much for preparing the workshop. Yeah, before we actually close or anything, I don't know if there are any other questions that people might have.
I would like to share something. When I saw the cover of this book, can you go a slide back?
Sure.
In the introduction to this book, R for Data Science, the person mentions it's for free, but you're very welcome to donate to these parrots. These parrots come from Australia, and they're almost extinct. So he just reminds you, yes, always for free, but let's share love and donate to these parrots so that they don't extinct.
Oh, that's nice.
Beautiful.
That's such a nice. Thank you, Margot.
Just to those who want to share love and gratitude to the creator of R for Data Science, knock yourself out and save the parrots.
That's great.
Beautiful. Thanks for sharing, Margot. I really didn't know that.
The link is in the introduction, the very introduction of this book. He just points you out to the website.
Yeah.
It still works. 1 month ago, I checked it. I was not able to donate from Dutch account, so I think you have to use PayPal or something else. And if you're going to donate, please let me know. I would like to do ideal to you so that you could
send Tiki. Okay. Nice.
Cool. Seems like we don't have a lot of questions. So we have the solutions ready.
Amazing, Nutsa. This was just great.
Thank you.
Thanks,
Thank
Margot.
you.
Really, really impressive. Seriously. I just needed to share that.
Thanks, Margot.
Thank you.
Yeah, so solutions I'll share right after this. Also the entire deck slide that you just went through. And yeah, I think if we don't have any more questions, I'm keeping an eye out on the chat. Then I guess we can finish a little bit earlier today and just let everyone rest well deserved. I think it's probably been a very long day for a lot of people. So thank you so much again for preparing the workshop. I think it was really, really nice having you, and also having all the slides and thinking so much about penguins. And of course, the tidyverse universe. So thank you so much, really.
Thank you. Thanks for having me and participating.